Alrighty, so today we are going to start with the last spread of our PowerPoint, and this is the last kind of topic for psych for year 10 this term, which is looking at research methods. So we're starting to understand this idea that yes, psychology is, underlined by the scientific method, and that the scientific method is connected to experimentation. It's connected to this idea of conducting research investigations. So we're going to understand a few of the basic concepts, which you probably already covered in other year levels of science, but we're just going to cover them again and just get our heads around them and just recap them basically. Okay, so the first thing we need to understand is this idea of sample and population. Okay, whenever we do an experiment, we always have a group of people that are taking part in the experiment, that are being experimented upon, or that are being exposed to some kind of treatment or some kind of task. Okay, so that's basically what we call as the sample. Okay, the sample is the smaller group of people from the population who actually take part in the study or in the experiment. Okay, so if we look at this example here with the triangles, you can see the population is the big orange triangle, and that the sample is kind of like a subset or a little group within that population, but these are the specific group that take part in the study or they take part in the experiment. Same thing with the ants here. You've got a big group of ants here, and if we decide, okay, I only need 9 participants for my study, or in this case 9 ants, we would count 1, 2, 3, 4, 5, 6, 7, 8, 9 from the population, and then that little kind of group within the population becomes our sample. Okay, this group then takes part in the study. So that's the important thing to remember. The population is the bigger, broader group of people. The sample is the smaller, more specific group of people who take part in the study. Okay, so just some examples. If I'm doing a study, if I'm doing an experiment, okay, when I say the word study, because I usually use these terms interchangeably, when I say the word study, I'm basically referring to an experiment. Okay, so they're the same thing. So let's say I'm doing an experiment on year 12 students. Okay, I want to look at year 12 students, and I want to look at how they use study techniques. Okay, so the effect of using concept mapping in VCE psychology students. Obviously, year 12 students who do psychology are my sample. Those are the specific people that I want to take part in my study. But those groups of that little group of students belongs to a bigger group of students, which is basically all year 12 students as a whole. Okay. In other words, year 12 students form that little purple triangle within the bigger population of year 12 students as a whole. Okay, so that's the difference between the sample and population. Same thing with university students. If I want to say that, okay, I want to do a study looking at the effect of class attendance on academic performance. Okay, so how often you attend your lectures and the effect that has on your assessment marks or assessment scores. So if I'm doing a study like that, in other words, I would be maybe recruiting first-year university students. Okay, but first-year university students are like little purple triangle. Okay, and the bigger group of people from which I would take these first-year university students would just be university students in general. So we're talking first year, but also second year, also third year, also master's level, also PhD level. So all university students would be included in that broader population there. Okay, so that's the basic idea. Okay, so population is the bigger one, the broader group. Sample is the more specific group of people. So you can remember that they're the more specific group, S, and that we select them. They're the group that are selected to take part in the actual study. Okay, so that's the sample and the population, and just remembering that the sample are the specific group of people who actually take part in the study. So now if we look at some variables in experiments, so now we've got a group of people who are in my study, okay, and who are ready to take part in my experiment. Now, what is the experiment about? Usually in a scenario or a research case study, you will be told, okay, researcher Thompson is investigating the effect of, let's say, the effect of red cordial consumption on hyperactivity levels. That's what's shown in the image here. Okay, so if we're talking about a particular thing that we're studying or a research aim, we need to remember that there's always a cause and that there's always an effect as well. Okay, so there's always a cause variable and there's an effect. Okay, you might have learned this in lower year levels that when we're talking about experiments, we're always talking about a cause-effect relationship that we are investigating. I think you guys also sometimes call it the if-then connection, okay, with reference to the hypothesis. We'll talk about that when we get to the hypothesis. Anyway, so the IV and the DV are really important for us to differentiate between, okay? The IV, in other words, is the cause, okay? It's the factor that we are manipulating, or it's the variable that we're manipulating, okay? What that variable then creates a change in, or what basically we're measuring for change, or the behavior that we're kind of observing to see if it changes, is the DV. That's the dependent variable. In other words, the dependent variable depends on the IV and how we manipulate that IV. Now, what do we mean by manipulation of an IV? What we're talking about here is this idea that if I do a study on the effect of red cordial consumption on, hyperactivity levels in children or behavior in children, I can vary or change the amount of red cordial that I give a child. So I can be like, okay, in this experiment, I want each child to drink 250 milliliters or 1 glass of red cordial. Okay, or I can vary that. I can say, okay, actually, I want them to drink 500 mils, which is 2 glasses. Or I could say, no, I want them to drink 750 mils, which is 3 glasses, okay, whatever. So with those different kind of amounts of cordial that I can change and vary in my experiment, I'm able to basically manipulate or vary this IV. And I know that by varying this IV, I will see a change in the DV. Hypothesizing or predicting that red cordial will lead to hyperactivity, which of these amounts of cordial do we think will lead to the greatest increase in hyperactive behavior? Is it going to be 250 mils, A, B, or C? Which one do you guys think? Put it in the chat box. So if we predict, or if we come up with the prediction that red cordial can or should lead to hyperactivity, which of the following amounts of cordial is most likely to lead to the highest level of hyperactivity? Yeah, correct. It's C. It's a pretty obvious answer there. So it's C, okay? The reason being that the more we vary or the more we increase that red cordial, according to our hypothesis, the more should be the increase in the hyperactive behavior. That's what we're predicting, or that's what we're hypothesizing. Okay, so that's what the IV is. The IV is always something that we can change. It's a thing. It's not a behavior. It's not something that we can observe someone doing like an action. It's not a pattern of, movement or behavior that we can easily observe. It's more of a thing that we can manipulate. Okay, the dependent variable, on the other hand, is a behavior in most cases. So it's some kind of behavior, some kind of action, some kind of pattern of something that we can observe, basically, and we can measure that thing for change. So for example, with hyperactivity levels, I can measure how hyperactive a child is based on maybe how many times they move around from their seat in the space of 1 hour, or how many times they jump up and down within the space of 30 minutes. Or I can measure something like how many words they speak in the space of 2 minutes. We know sometimes when children are hyperactive, they talk a lot more. Okay, so there are many ways in which we can measure one factor like hyperactivity or one DV. Okay, and we'll talk about that a little later. That's actually called operationalizing the DV, or basically talking about how we can measure a specific behavior. Okay, now I'm going to give you guys a scenario in the chat box, and I want you guys to pick out what is the IV and DV for that scenario. So I'm just going to put it in now. So let's say I'm going to choose one of your names. So researcher Abbas is investigating yeah, let's just stick to that. Okay, guys, what do we think? Just tell me what you think the IV and the DV is there in that scenario that I've just posted in the chat box. Good, so we've already got some good answers coming up. So I want more people to give it a go. You can take a guess if you don't know for sure, it's okay. Just give it a go, just give it a try. What do we think? Good, so most of you are saying that it's the IV is the sports drink. Yeah, and that the DV is the athletic performance. That's correct. Okay, the sports drink is what we're varying. Remember, just like the cordial, we can decide to give the athletes maybe 1 bottle of Gatorade, 2 bottles of Powerade, half a bottle of Powerade, whatever. Okay, whatever sports drink we're giving them, we can actually choose to vary that amount. Okay, so that's sports drink because we can vary this or change the amount, in other words. Okay, and for this reason, we say that the sports drink is actually the cause. Athletic performance can be measured. For example, can anyone tell me just general knowledge? There's no right or wrong answer here. What's one way in which we can measure athletic performance? Or one way in which we might be able to gauge that variable or gauge that athletic performance? Any kind of specific things that we might look for? Their speed, yep. Reflex time, reaction time, stamina, excellent. So all of these things, for example, stamina, speed, reaction or reflex time, all of these things can influence a person's athletic performance and can be a measurement of their athletic performance as well. Okay, so stamina to maybe run 800 meters, okay, and how long it takes them even. And we can link that back to endurance as well. Okay, so all of these things can be affecting athletic performance or can basically be how we measure someone's athletic performance there. Okay, so that's good. So you can see here clearly DV is what we're measuring for change, athletic performance, and the IV is the thing or the object or the stimulus that is supposed to cause that change or cause that change in a person's athletic performance. In our next class, we're going to talk about this idea that there are other factors that can also influence the DV, which are not the IV. For example, how much training someone does out of out of school hours, or how much what a person's diet is like. All of those are other factors other than the sports drink that can still have an unwanted effect on the results. But we'll talk about that on Wednesday's class. Okay. Okay, I'm going to give you guys one more scenario in the chat box, and then I want you again to just identify the IV and DV. So let's say Professor Layla is conducting an experiment on the impact of green tea Okay, so I haven't mentioned any kind of sample or population here, but I've just given you 2 variables. So can everyone take a guess? What is the IV there and what is the DV? And then we'll just open up another box here and write our answers. Good, having some good answers there so far. I need more people contributing. Come on, there's 17 of us in here. Good, most of you are on the right track so far. Excellent. So every one of you, all of you have said that green tea consumption is the IV, which is correct. Yeah, green tea consumption is the IV. What we're measuring for change is basically going to be the weight loss. Okay, or you could even say the amount of weight loss or whatever. Okay, amount of weight. Oh, you know what? Let's just keep it simple. Let's just say weight loss. Okay, cool. So now we know that the IV is something that can be varied. So just like the other 2 examples, I can vary the amount of green tea I want my participants to consume. Or sorry, Layla can vary the amount of green tea she wants her participants to consume. So for example, she might tell her participants, okay, I want you guys to have 200 milliliters of green tea every night. Or she could say, I want you to have 300 mils of green tea first thing in the morning when you wake up. Or I want you to have 400 mils of green tea in the middle of the day, right after you've had lunch. Okay, so that could be how she varies that variable. Okay, not just in terms of the amount she wants her participants to drink, but also like what time of the day she wants them to consume that green tea. So that's a very something that can be very easily manipulated or easily varied or changed in terms of the amount. All right, now we're looking at weight loss. This is a pretty straightforward question, but how might Layla measure weight loss in her participants? What are some common ways in which we measure the variable of weight loss? Yeah, can be measured using a weighing scale. We can see the loss in kilograms over a specific amount of time. Yeah, that's good. We can weigh them in the morning versus like before they go to sleep. So loss in kilograms in morning versus sleep time. That's good. We can also talk about maybe getting them to do a self-evaluation. Do they feel like their clothes are a bit looser than before? Do they feel like they look a bit more slim than they did before? Okay, so these kinds of measures can be ways that people can, judge whether they've actually lost weight or not. Okay, and Layla can actually measure weight loss using such measurements. We can even measure people's like waist circumference. Okay, that's a common way in which weight loss is also measured using that little kind of tape measure, measuring person's like waist circumference, how much they might have lost on their hips, all that kind of stuff. So that's basically a DV because we can easily measure that variable there. Okay, and we can easily track changes in that variable. Okay, now that we seem to have a pretty good handle on IV and DV from the looks of it, what I'm going to do is I'm going to show you guys a quick video on IV and DV just to kind of recap, and then we're going to come back and look at the rest of the topics. So I'm just going to pause the recording here while we watch the video. So we've looked at this scenario and we've looked at this idea that the population was first-year university students. We've looked at the idea that the IV is green tea. We've measured that or operationalized that as them drinking 250 mils of green tea after dinner for 2 weeks. That's all given in our scenario or our question. What are we expecting to see in them now? What change? We're expecting to see a change in their weight, correct? Okay, will experience maybe decrease in weight. Okay, that's what we're expecting. We're expecting to see weight loss, or you know what, let's be more specific. Let's just say we'll experience weight loss. Okay, how are we measuring that weight loss now? How are we operationalizing that variable? Just look at the scenario and then just let me know and I'll fill that up. Weight loss is our DV. Yep, as measured by, so we'll experience weight loss comparing the kilograms lost before versus after experiment. That's correct. And then the last part is actually where we mentioned the control group. Now, we haven't actually looked at the control group yet in this PowerPoint, but I'm pretty sure from previous year levels, you guys probably have some idea of what the control group is. Can anyone give me a quick definition or quick description of what you think the control group is? Or if something is acting as a control, what does that mean? Okay, the control group is basically the group, guys, that is not exposed to the IV. Okay, it's a bit different from controlled variables. This is where VCE terminology can be a little bit confusing. Controlled variables are variables where we have to make sure they stay the same. A control group, on the other hand, is basically a group that is not exposed to the IV. So you know how, for example, in an experiment, we have a bunch of people in this experiment who are drinking the green tea. We need another group to compare their results against. And in that other group, that control group, these participants in the control group are not drinking the green tea because if they're drinking the green tea, we can't really tell if there's going to be any changes in the actual green tea participants who are drinking the green tea, who are our experimental group. So what I would basically add to the end of this to get full marks for my hypothesis is just mention the control group. So compared to the control group, or in other words, I would write compared to students who do not drink green tea. That's it. Okay, that's the control group, because they're the participants who are not exposed to the IV, so they are not drinking the green tea, in other words. That is the hypothesis. So if you're, and this is like probably a really good hypothesis, okay, probably more than what we should expect at year 10 level, but if you can write something similar to this, there's no reason why you shouldn't lose marks there. It's just a matter of, again, like I said, following the template that's there for you, okay? And if you follow that template, you can't go wrong. All right, cool. So anyway, we'll focus a little bit more on this in the worksheets as well. When you guys do the worksheets on Friday, we'll look at that a little more. But hopefully that makes a bit of sense as to what a hypothesis actually looks like. It's just like you guys said, it's just a prediction. We're just writing that prediction in words in a few sentences. Okay, that's the research hypothesis. So we just have another one topic to cover before we finish up for today. Experimental research. Look, this is really just a pretty straightforward slide. There's nothing in here we haven't already talked about, or you probably haven't already learned. An experiment just looks at a cause-effect relationship between variables. Usually experiments are conducted in controlled conditions. Can anyone give me an example of a place that acts as a controlled condition where experiments are usually conducted, or that we see experiments usually being conducted in? Yeah, a science lab. Yeah, a science lab or a laboratory is basically a place where experiments are conducted. Why? Because they're controlled conditions. I wouldn't go to the middle of the school courtyard and start conducting an experiment with highly volatile chemicals or things like that, because certain factors like temperature, if it starts to rain, it could be hazardous. If it starts to, if there's too much humidity in the air, it could lead to a different reaction. So for that reason, a lot of the time we conduct experiments in labs. Now, what could be one issue, not so much with, and this will be more with like a social psychology context, but when we actually do experiments that don't involve chemicals, for example, experiments where we're looking at children's behavior or how kindergarten children communicate with one another or interact with one another. When we're doing those kinds of experiments and we're doing that in a lab setting as compared to a real life setting, one of the issues that we have is that people are less likely to behave in a realistic way, or they're more likely to behave in an artificial way. Okay, sometimes when you're put in a lab, all these, like this unfamiliar external environment can cause you to behave differently. Okay, that's one of the limitations of an experiment. Okay, the fact that it is conducted in controlled conditions and that can lead to artificial behavior compared to more realistic or genuine behavior. We've already talked about the idea that the IV is the cause, the DV is the effect. This is another example which already gives you the answer. If you're doing an experiment on the effect of being sleep deprived on academic performance, we know that what we're measuring here for change is the academic performance, or maybe the percentage that you get on the test. And then what we're manipulating there is the variable of sleep deprivation. So how sleep deprived are you? Are you sleep deprived in the sense that you've slept 5 hours less than normal? Are you sleep deprived because you've slept 2 hours less than normal? Okay. And obviously, the more you're sleep deprived, the more we would expect your percentage score to go down in our hypothesis. Okay. And the less sleep deprived you are, we would expect that your percentage academic test score would probably be a little higher than the people who are more sleep deprived. Okay, that's the basic idea. Okay, so let's just move on to the next slide. This is the slide that I was talking about before, talking about the control group. So the control group is the group in the experiment that's not exposed to the experimental condition. When we say experimental condition, we're just talking about the IV, okay? IV and experimental condition are the same thing. Okay, and we call the IV the experimental condition because the experimental group is the group in the experiment that are exposed to the IV. In our previous example, the experimental group were the group of people, who consumed the green tea. Yeah. Or for example, in the previous example we had before that, the group who had the sports drink. Okay. In each of those experiments, you'll also have a control group, and the control group is basically would be the group who did not consume the green tea. Or for the next example, the group who did not have the sports drink. Okay, so that's the basic idea. The control group is literally just the same kind of people as the experimental group, but the condition they're exposed to or what they do is different. They kind of do the opposite of what the experimental group do. Okay, the control group is important because they act as a baseline for comparison. We use them to just compare the results of the experimental group to see, okay, these are the standard. Now, how far from the standard have the results changed, in other words? Okay, that's the control group. So remember, control group, no IV, experimental group are exposed to the IV, or there is an IV there. Okay. Okay, this is for next time. We're not going to start unwanted variables today. All right, so that basically covers, I need to show you guys 2 more videos, so we might just watch those videos, but that basically covers the half of spread H that I wanted to cover for today. So I'll just pause the recording here